Hello everybody and welcome back. Jim Halen here again for the last session of the class. So welcome to session 8. So just a couple of reminders as far as the schedule. On Sunday the 26th, the goal paper is due by midnight, and then your final assignments, which include the final summary paper and the paper that you're going to write summarizing your experiences with the second simulation, are both due on the 4th. So let me know if you have any questions on that, but that's what's in the syllabus schedule since day one, so hopefully your efforts are in alignment with that. You've completed the second simulation, variety of results as anticipated, nothing I haven't really seen before as far as the goods, the highs, the lows, whatever. But you all worked hard at it, and I appreciate that. So let me just go into a brief summary, and then we'll wrap it up. So, as is often the case, a brief review of what we covered last week, and that would be quality. So we talked about the fact that whether you're delivering a product or a service, quality is the end-all overall goal. So the whole idea is that delivering the thing that you promised you would, whether it's a physical product or a service, is what quality is all about. And a big part of this is the process. So how does the process drive your success? Without a good quality process, it's hard, and very hard, to have good quality products and services on a consistent basis. So again, key part of the quality cycle. We talked about the evolution of quality, starting with quality control, where you're inspecting in quality, to quality assurance, where you're designing good quality products and have good processes, to ultimately quality management, where you have the overall end-to-end processes in alignment, and you've got an overall corporate environment and management support of quality from end to end. One of the keys to quality is the idea of how do I measure and control quality. And this is one of the topics we talked about before. It can be very difficult sometimes, especially with some services, to define quality. Quality is in the eye of the beholder in a lot of ways, especially if that beholder is the customer. So sometimes it's not always easy to figure out exactly what the customer is looking for, and then how do you quantify that? So the overall process is, number one is defining it. How do you identify what's going on? How do you define what quality means to you? If you think about a service, how do you measure that you've delivered the right service? Is this based on repeat business? Is it based on customer feedback? Whereas with a physical product, you can say, hey, this product is going to, like a car, for example, is going to deliver a certain amount of horsepower. I can put that car on a dynamometer and figure out how much horsepower I'm getting. So it's a little bit easier to measure. However, with a car, you could also argue that, from a style perspective, do people like the style of the car? That's a little tougher, a little bit more like a service, if you will, to try and define. So assuming you define it successfully, then how do you measure it? How do you quantify where you're at? Are you above goal, below goal? Are you delivering on your commitments or not? And then analyzing that data. Do we have a trend? Are we doing better over time? Are we doing worse over time? How do we figure out what process changes need to be made? And then improving is the step of making them. What am I going to do differently? And am I going to change certain components in the product? Am I going to train my employees better? Am I going to come up with better ways to define product? Am I going to work with my suppliers to improve the quality of what they're delivering? So again, how do I improve it? And then control it. How do I make sure that I have a control plan? How do I monitor things? How do I mistake-proof the process? These are just at a high level what I'm going to try to do. So when you think about mistake-proofing a process, a lot of times in a factory organization, we always think about the round peg and the round hole and the square peg and the square hole. If I have that situation, the odds of putting the round peg in the square hole are minimized. The simplest example you can think of is the outlet in the wall. If you have a three-prong plug, you can only plug that plug in one way. And so that's an example of mistake-proofing a process. But a lot of things can help you, and really control is, in general, the least glamorous part of this. How do I keep the thing running day in and day out with good control, with the right processes, the right steps, the right outcomes for my customers? And so that's like an overview of what the one of the keys to a good quality process is all about. We talked about metrics, and I want to emphasize metrics again because metrics really make a big difference. If I'm measuring things, I can improve quality. I know what the customer wants. If I have a bunch of people just doing the job, and I keep, in the management overall response is, hey, you guys are doing a great job, just keep doing it. But if I come in and say, okay, here are the specific metrics that collectively we're going to work against. We're going to measure these. We're going to base our quality goals on this. We're going to do cost reduction, cycle time improvements. Again, metrics are not just about quality. It's about every step of your process. I can reduce waste. I can have better internal processes and products. And ultimately, I can use it against performance reviews. And the goal from a performance review standpoint is to challenge an organization, not to be punitive, but to challenge an organization to find ways to improve. Whether it's individually or organizationally, that's kind of the goal. So without further ado, you all probably saw the results in the simulation, but Natalia Maidbray came out on top. I like this graphic because we have a lot of exhaustion among the players. And but again, congratulations, Natalia. Your overall plan, your strategy came out on top. Not to say that other people's strategies weren't good, but yours came out on top, and good for you. A little bit to talk about the simulation itself. As I mentioned earlier, everyone got the same order inbound materials. Not materials, but the order inbound volumes. This was a graph of that. So you should have seen something similar to this for all of your inbound order volumes. So my favorite do nothing team, as promised, did nothing. So as you can see, similar to the first simulation, the do nothing team made a good solid $750 every single time, like a rock, no problem. Since I didn't change anything for the do nothing team, we didn't have more aggressive goals, so I didn't have to worry about missing those more aggressive goals. On the right, and I tried to scale these to be roughly similar, and I added a dotted line here. If you looked at your own results, this dotted line was not there. That dotted line represents the do nothing team. So I look at this team, and again, I won't play favorites. I just grab two teams from the results. And if I look at this team, well, you can see by going to the red and the green, this team selected more aggressive goals. As a result, was able to get revenues in excess, not always, but in excess of what the do nothing team. So on average, this team had more revenue, more money coming in, so they did better than the do nothing team. This team, on the other hand, had some problems. They made a commitment to a more aggressive goal and couldn't meet the commitment. As a result, we saw a huge problem here and a huge problem here, a whole lot of revenue opportunity lost. So if you look at the difference between this team and the do nothing team, this whole area here and this whole area is revenue that was lost. It put them behind the do nothing team. So if I look at that, I said, why do you have revenue? Well, revenue is driven by your cycle time. If you had to commit to a more aggressive cycle time goal or lead time goal, if you did and you made it, that's great. If you did and you didn't make it, you lost money. So I use the same two teams. So you look at this team, you say, okay, I put a dashed line at the 2 level. And so here, the do nothing team, we were, generally below 2, but not always. Look at this team, not always below 2, but quite a bit below 2 for most of the simulation. So the fact that this area is here means opportunity to make more money because I had an opportunity to commit to more aggressive goals. This team, quite the opposite. Again, you notice the scale difference. This is 3, this is 18. So here's that 2 line again. So this area here compares to this area here. So again, stayed below the goal, committed to a more aggressive goal, and somehow at the same time got much worse. Got even worse, to the point where down at the end here was able to recover, get back below that line, but tough road. So all this area inside of here times when the lead time was missed heavily, and as a result, revenue was lost. Finally, the completed jobs per day, that kind of drove your cycle time. So again, you can see the progression. Revenue is driven by cycle time. Cycle time is driven by how many jobs I'm completing every day. Here, nice little level here, around 8 jobs per day for the do nothing team. I put that same line on these other graphs. Notice here, regularly quite a few more jobs per day. So obviously this team had more capacity, had done a better job of getting their effective capacity understood and managed. Here, similar problem, except all of a sudden here we got, oh boy, we got a problem here. We committed to a more aggressive time frame, didn't get it done, and managed to get fewer jobs per day done, thus driving my cycle time losses, thus driving my revenue losses, until finally at the end everything kind of wiped out. So what I want to do is thank you all, and I know this was a brief video, but kind of the way it works at the end as we wrap it up. So I want to thank you all. To summarize very quickly for the simulation, a large part of it has to do with managing your process and understanding your process. Did you need to buy a lot of equipment? It couldn't hurt, but the money spent on equipment tended to drive up or drive down your revenues. And again, you had to be careful to make sure you had enough money to buy raw material. So saw a lot of action, a lot of good thought went into this. I look forward to seeing the papers and providing feedback on that. I hope, in summary, for the overall class that you enjoyed it. I know it's a lot of work. I know for a lot of you it takes you into a space that can be tricky for you. And what I mean by that is a lot of the math and analytics can be difficult, and so I saw a lot of good results from a lot of folks. So again, I appreciate that, and congratulations on that. I think the biggest thing I wanted you to walk away with from the operations management class is the idea that it's all about the numbers. It's not about whim. It's not about calling the shot in the traditional sense. It's all about the numbers. So, and the numbers and how you define them, how you respond, all comes back to your overall strategy and your decisions of operations management. So, I always structure a lot of the content around the SOCA and the DOMS, and that's really what drives it. You start with your SO, you go to your DOMS, and then go to your numbers. So if I look at the SO, starting with your strategy of your operation, it has to be based on the strategy of your overall business. We talked a little bit about strategies. We talked about the type of strategy that your business is founded upon, and your organization has to support that strategy. If the overall business has one strategy and the operation has a different strategy, you won't have congruence between the two organizations, and you won't be successful. So once you have your business strategy, your operations strategy, and then look at your competitive advantage, make sure that everything is in alignment, then you can look at your decisions of operations management. The 10 key decisions, not that there aren't others, but those are the keys. And they're there so that you make sure you look at the entire scope of what's affecting your operation and understand where you're headed. And then finally, you want to take a look at the numbers. From that point, it's all about the numbers. How do you make those decisions? The DOMs are guides to help you decide what decisions to look at, excuse me, what things to consider. But then you have to apply the numbers. You have to look at it and say, well, I can build a plant here or build a plant here. What are the numbers? What are the costs? What are the demographics? The availability of employees, the availability of transportation. So it's all looking at very logical approaches to these things. And obviously, if you get to where you have a tie between two choices, you have to look at forecasting. And we spent quite a bit of time talking about forecasting. And the bad news about forecasting is the most expensive activities are the furthest ones out. Building a new factory may take a couple years, but my forecasts are weaker at long range than they are at close range. So I have to get better at forecasting, and the only way to do that is by doing forecasts, understanding the outcomes, seeing how you did, and adjusting your methods based on that. So it can be very tricky. It can, but if you apply logic, if you go through your forecasts have a strong team of folks that you're working together and everyone is open and honest in their feedback, your opportunities are good and your success will be more likely. So with that, again, I want to thank you all. A lot of hard work went into it. I appreciate your efforts. Hope to see you around again, and wish you good luck in your future studies. Take care.